welcome, and there's been quite a bit of news lately about data and the way that data is reported in the UK and in the US. Now, of course, you expect made-up data from certain countries such as, well, I'll leave you to complete the list, but the list is long but distinguished of countries where the data is not reliable. But we do expect reliable data from the US and the UK. Now, what is going on here? Let's try and work out what's happening, because I think this is so important, not just for this pandemic, but just so important so that we can trust people that are supplying us with official data. Now, the US first. Now, historically, the Centre for Disease Control has been the place where public data has been sent in relationship to disease and illnesses. And this is good because it gives access for researchers and the press, for reporters, and indeed for members of the public who want to take an interest in such a thing as a pandemic or an outbreak of disease, for example. Now, up until last week, 25,000 medical facilities across the United States reported daily to the National Healthcare Safety Network. And this is an aspect of the surveillance operated by the Centre for Disease Control. It's an online system operated by CDC. And the Centre for Disease Control, via this National Healthcare Safety Network, published relevant information on the state of the pandemic. But as of July the 15th, 2020, hospitals could no longer report COVID-19 data to the Centre for Disease Control. It had to go straight to the central government office. Now let's look at that and see what's happening here. So I've put plenty of references on here because I don't want to be saying the wrong thing, because it's quite an important issue. So these are all in the description, obviously. You can just look them up and browse through them yourself. But the headline is the CDC is being bypassed in the collection of COVID-19 data. The Department of Health and Human Services, apparently, has ordered hospitals to send all COVID-19 data information to a central database in Washington, D.C., as I understand it, run by this Department of Health and Human Services, which is in Washington, D.C. This is centralised. Now, this is not something that hospitals have an option in, as I read these reports. It seems to be a federal order. Hospitals are now required to submit COVID-19 data directly to this Department of Health and Human Services in Washington, D.C., instead of the Centre for Disease Control, as of the 15th of July. So that's what these reports are saying. Now, of course, the reason giving for this is going to make the data more streamlined and faster. Data will be more accessible more quickly. But this data apparently is not accessible by the public. So if you want to find out directly, as we'd say in England, tough ched, you can't do that. Now, the hospitals do have an option to report to state officials, but the state officials apparently have to send a written disclosure or disclaimer to the individual hospitals to allow them to do this. So whether this will be done in practice or not remains to be seen. Let's hope that the states, who of course in the United States have a high degree of autonomy, let's hope they exercise this right and publish data that can be used for the benefit and healthcare decision-making processes of their citizens. So, slightly concerning development there from the United States, really. The idea that it's going from the Centre for Disease Control, which has been collecting this data for, over 100 years, I think. And now it's going on to a data collecting system which is not accessible to the public. The real reason for this, you tell me. I really don't know. So, slightly concerning news there from the United States about the way data is collected. Now, in the United Kingdom, there's been a similar not similar, but there's been other talk this week, and it relates to this. This one's a little more straightforward, really. Daily updates on English COVID-19 deaths have been paused, and again, plenty of references. Now, basically what's been happening here is currently the daily deaths measured are counted on everyone who's tested positive for the virus. So what's happened here in the UK is that people are tested for coronavirus, for COVID-19, and if they're positive, they then go on like a list. And then if they subsequently die at any point in the future, then that death is counted as a COVID-19 death. There's no cut-off point. And of course, that person could have died of anything. They could have died of a heart attack, or they could have died of a trauma or another disease. All it means is they've been tested for positive at some point and then gone on to die. But of course, everyone goes on to die. It's just a case of when. So that's what's been happening in the UK. So it's more of a... This is more of a mess up, really, by Public Health England. I can't say I'm impressed, actually. So currently, the daily death measure counts all the people who've tested positive and since died, regardless of when they died. No cut-off point. Public Health England regularly looks for people on the new database who have ever tested positive and simply checks to see if they're still alive or not. Excuse me for sniggering here. So, I mean, the simplicity of this it really beggars belief. So here we have Public Health England, who's supposed to be this all singing, all dancing government body. And the way they can manage to record deaths is they do a test. Then they just compare the people that have tested positive with people that have died and said, oh, they've died now, we'll count them as a coronavirus death. I mean, Public Health England, come on. And as far as I know, it's not Public Health England that have worked this out for themselves. I think they had to be embarrassed into changing. So seriously unimpressed Public Health England. You know, get your act together. That is not impressive. In Scotland and Northern Ireland, they manage it. They've got a 28-day cut-off. So in other words, in Scotland and Northern Ireland, if you get tested for coronavirus and you die within the next 28 days, that's counted as a coronavirus death, which is reasonably accurate. But if you die 29 days later, then that is assessed independently and separately. Not so by Public Health England, to their embarrassment now, I am sure, because this is not an impressive performance, Public Health England. So after which the patient who is tested positive is not automatically considered to have died of the virus. That's in Northern Ireland and Scotland, where they're doing quite well, unlike England, where this has been handled unsatisfactorily. And international comparisons are misleading because countries record deaths differently. So this has got really massive importance, I feel, because what is happening really at the moment is a series of experiments. This is a novel virus. We don't know really the best thing to do. We've got some pretty good ideas. But a fascinating way to proceed is to compare one country to another. How has the strategy in this country worked? If you like, it's a countrywide experiment. And of course, we've got 170, 180 countries in the world. Let's compare the way they all do, and that could give us really quite valuable data. But we can't really do that because we can't compare apples and oranges, because the way that the data is collected in different countries is different, which is a pity. So what some academics need to do is they need to look at the way that the deaths are counted in various countries and work out a way of equalising that, so that there can be consistent analysis of the deaths in all the different countries of the world, and then there can be legitimate comparisons. Now, it's possible, for example, when you do meta-analysis, there's something called Z-scores that can do this. So that's really a job for some statistical, epidemiological academics who could do that, and I think it would be well worth the while doing that, because that could get us some really valid, what is essentially experimental data. Now, better news. The UK. Where are we? The UK planning to carry out millions of antibody tests. Now, to be fair, way back in February, we reported on this channel that the UK had ordered about 3 million antibody tests from the Chinese, but they didn't work. Had to send them back. So the science has taken quite a long time to catch up here, really. But Oxford University, in partnership with leading UK diagnostic firm Rapid Test Consortium, UKRTC, Rapid Test Consortium. Now, this new test is pretty accurate, and it takes 20 minutes, and it's an antibody test. So it's testing for the body's immunological reaction to the virus, as we've said many times, as you know. Now, apparently, it's reported from initial trials as having a 98.8% sensitivity. In other words, it only misses 1.2% of actual positive cases giving a false negative. So that makes sense. So it's 98, it's right 98.8% of the time. That means it only misses 1.2% of people that are actually positive. And it's reported to have a 98.4% specificity. That means it gives a false positive in 1.6% of cases of people who are actually negative. So this is pretty good. So we've got a low rate of false negatives and a low rate of false positives. And they're hoping to have millions of these tests by the end of the year. It's just one of these little plastic things, literally that size. Literally that size. And it's got a place on the bottom for your blood sample. You put your fingertip. This is not an intravenous blood sample like is being done at the moment. So fingertip blood test, squeeze the blood on there, and then it goes up there. And I imagine what you'll have is you'll have IgMs there, IgGs there, and a control at the top there. I imagine that's what it'll be like. So looking forward to seeing one. If the manufacturers would like to send me one, I'll do it on myself on camera. Of course, that would be very interesting. Millions by the end of the year. Planning to test healthcare professionals first, then millions of people to use at home. Good. So significant progress. Now, once people have used this, they'll send their results to a central database. So we're collecting lots of additional data here, all remarkably useful. So people will be sent a test kit at home. They'll carry out the test kit at home, and then they'll send the results into a central database. Each kit will come with a box with a QR code, so a barcode, and instructions. Now, it uses the full-length spike protein. Now, what the problem has been here? So basically, remember, this is a test for the antibodies. It's a test for the antibodies. In fact, I'll come back to that bit. I'll just tell you about that in a minute. I'll just finish this bit. And it's designed specifically to capture the IgG antibodies. Now, as you probably remember, there's two main types of antibodies that the body produces when it's exposed to a virus. First of all, it produces immunoglobulin type. Ig stands for immunoglobulin type Ms. They're produced first, and they last for 23 days in the blood. Then it produces immunoglobulin type Gs, and they're present for about 49, 50 days in the blood. Maybe more days than that if it was a big infection. So really this has got to be done within, 50, preferably a few weeks after the infection. Because if you tested someone, say, 60 days after the infection, even if they'd had the infection, the antibodies would probably be gone. They probably wouldn't be detectable. So there's no point doing this test 3 or 4 months later. It wouldn't tell you anything. But it's using the full-length spike protein. So what you have is, in the blood, you would have the antibodies. So the antibodies are basically something that's going to be this kind of shape, like this. So imagine that's they're actually going to be Y-shaped like that. And they'll have this bit on the end like that. So this is roughly what the antibodies are like. So that would be the antibodies. Now, the thing is, these antibodies fit into the spike protein. So these antibodies would fit into the spike protein here like that. And this spike protein is the spike protein that grows off the surface of the virus. So if that's the virus there, as we've seen in previous diagrams, it has these spike proteins sticking out of it, like this. So it has these spike proteins, like that. And that's good because this is not drawn to scale, of course, the antibodies will be much smaller than this. So this is the antibody that the body makes. That's the antibody that the immune system makes, and this is the virus, is the antigen. But now, of course, we're testing for the presence of the antibody to see if someone's had the infection. So what this test must have, it uses the full-length spike protein. So in this antibody test, you'll have these full-length spike proteins here, like this. So these proteins are the same as the proteins, these spike proteins that you get on the virus, like that. So in other words, this is viral type material here. You don't need the whole virus, just the spike proteins, because these are specific. The molecular shape of the proteins on these spikes are highly specific to this virus. They're highly specific to this virus. So these will be waiting in that strip there, like that. And if the correct antibodies come along, then these antibodies will connect onto these, like that. So that part of the antibody there is this part of the antibody here, the part that actually recognizes the virus. And then when these antibodies connect to these viral analogues, or these parts of the virus here that are in the test, then that will give you a nice bright coloured line, and you'll know that you have the antibody. So the reason this test seems to be good is they're using the full-length spike protein. So that means it's highly specific. So only the COVID-19 antibodies will fit onto it, giving rise to this nice white line. So the downside is we're not going to have millions of these tests until probably near the end of the year. But hopefully they can bash them out cheaply and bash them out by the million. And hopefully we'll make them available to many, many parts of the world as well. So we're going to have these antibody tests way before we have the vaccine. I'm pretty sure about that. So that was some good news. So far in this video review, we've had bad news from the United States that the data is not going to be processed as it was once processed. That's putting it as politely as I can. We've had bad news from the UK that Public Health England have botched up the way they've been collecting their data. And now we've had good news that the antibody tests seem to be coming, but they're not coming quickly enough, unfortunately. Well, not as quickly as we would like. So these are the few things that I wanted to cover on this video. Now there's one more thing I want to mention, and that is, watch the video. It was an old video, but the director from the Centre for Disease Control, Director Redfield, seems to want everyone to have the flu vaccine in America. Now this is the same as the situation in the UK. Everyone seems to be going flat out to vaccinate everyone against influenza, and this is good. This is understandable, because what it means is we're going to have the influenza season this winter. That's going to happen for sure. But we don't want people to be getting COVID-19 and influenza at the same time, and we also don't want the diagnostic difficulties. Now, to be fair, it's not a massive problem, because in accident and emergency departments, we can actually take a sample, a nasal sample from someone, and we can put it into a little machine that's usually on the department, and it will tell you within about 20 minutes whether someone has influenza or not. So we can test for the presence of influenza quite readily. But of course, that's an in-hospital test. It's not an easy at-home test. So it would be ideal if we didn't have any influenza at all this influenza season. That would be the ideal situation. So it makes sense that you want to give lots of people flu vaccine to reduce the amount of influenza massively. But the only downside in my mind is we did look at some research that showed that people who have had the influenza vaccine are more prone to other respiratory viral infections. Now, I don't think that's going to be a problem, as I've said before, but it does slightly concern me that the Director for Centre for Disease Control and the chief scientific people and medical people in my country don't seem to be considering this. Now, perhaps, to be fair, they've considered it, found out it's not a problem and said, no, go ahead and vaccinate everyone. That may be the case, but they haven't said so. So it would be good if they said that so that we could be reassured, and then we would all trot off and get the flu vaccine as per the government's wishes. And if we're given, we do seem to be given the all clear to do that. It would just, personally, I would feel it nice just to have that little bit of reassurance. So some interesting bits and bobs of news there. Thanks for sticking with that. I'm just going to show you a few pictures of you good people now. Sorry, it's been a while since I've showed you any pictures. And we want to be on the second screen. There we go. Good. So this is Abby in Philadelphia. So Abby's practicing with her masks ready to go out. So that's good. And Abby is also an artist, and she's done this picture here of levitation of a lucid dream. Excellent. I'd love to be artistic. Now, I'm not going to go on too much about it today, but the lucid dream experience is a particularly interesting phenomena in sleep science. So the lucid dream experience often involves waking up where you actually are and then things happening from that position. So you wake up in bed and then you have the dream, and of course it's all real. But of course the only thing is you haven't woken up, you're still asleep. It's a lucid dream. So a lucid dream is one which can't be distinguished from reality. And of course, these can be quite. This picture looks like quite a nice one, but they can also be a very disturbing experience as well, because you can wake up where you are, and for example, you can have what's called night entity attack. So you wake up in bed and you realise you're paralysed, and then this frightening person walks into your room and you can't move, or a frightening entity. Sometimes it's a hideous old woman who walks in, and sometimes they'll sit on the chest of the person and they can't move, and it's all real. They're awake. They just happen to be in bed to them. But of course it's not real. They're dreaming, and then eventually they'll wake up and realise it's a dream. So it can be very frightening. So the lucid dream experience can be very frightening, or it can be an amazing, liberating experience, as we see in Abby's picture. Sorry, I didn't mean to tell you that. Just an interesting tidbit there. Just a few thoughts that were stimulated by Abby's excellent picture there. This is Linda in Ontario. Good to see you watching in Ontario in Canada. Linda, thank you. Linda's taking D3. Thanks for the picture. This is Neil and Cara, and they're in Bloemfontein in South Africa. I'm glad to see they're practicing with their masks ready to go outside. So we have been reporting on South Africa. There's a lot of increasing cases there. So it's good of Neil and Carla to take the time to send us the picture. Thank you. This is Tyler and Renee in the United States. Not sure where in the United States, Tyler and Renee, but lovely picture. Thank you for sending that in.